AP Calculus BC, day 7, or Unit 7, Day 3, office hours. These are problems out of the Kennedy book, our newer book this year, the orange one. 2 different pages. I told you not to do 38. These are the evens, so you can check these real quick. I should have checked your odds in the back of your book, but these are the evens. So check these. Pause the video if you need to. All right. So let's try these out. So first 2 problems say to use like a graphing calculator. I told you not to, so we're just going to do them by hand. It says find the average value of the function. At what points on the interval does the function assume its average value? So the C values or X star values or whatever. So 11, the function is y equals x squared minus 1, 0 to root 3. Zoom in here. Okay, so we need to find the average value first. So f average is remember it's like the area of the curve smoothed out. That height of the smoothed out curve is your average value. But now the smoothed out curve looks like a rectangle. It has the same area as the original curve. Divide by the base, you get the height. So we're going to integrate, find the area under the curve, but then smooth it out. Now it's a rectangle. Divide by the base of the rectangle, the positive difference between the limits, and that should give you the height of the rectangle. So 1 over the square root of 3. The antiderivative is going to be x cubed over 3 minus x. So we're going to get 1 over root 3. 3 root 3 over 3 minus root 3. Simplifying as I go. Minus 0 minus 0. So, wow, it's going to be 0 because that's root 3 minus root 3 is 0. That's 0. The average value is 0. Interesting. And now we're going to see it should have at least one place where the actual value equals the average value. So we're going to take the original function, x squared minus 1, and set it equal to the average value and solve. So x squared equals 1, square root of both sides, plus or minus, x equals plus or minus 1. So we only want the values that are between the endpoints or including the endpoints. So that would just be the positive 1 value. Okay. Okay, 14, same directions, y equals x minus 1 squared, endpoint 0 to 3. So we have to first find the average value by integrating the function, which I think we should probably go ahead and FOIL out because we're not using a graphing calculator, and divide, and then we're going to go 0 to 3 and then divide by the base of the rectangle. So we're going to get 1/3. Antiderivative is going to be x cubed over 3 minus 2x squared over 2 minus plus x. So 1/3. And so that's going to be 9 minus 9 plus 3. And plug 0 in, 0 minus 0 plus 0. And so the average value is 1. These are working out very nice. That's the average value. Then we're supposed to find the place where the actual function, value of the actual function equals the average value. So we're going to set them equal to each other and solve. We could do the square root of both sides, plus or minus right now. That'd be easier. It's like a complete square. You don't have to. You can do a bunch of extra work and then undo it later. That's going to be plus or minus 1. There's 2 solutions, quadratic. We're going to add 1 to both sides. So one answer is 2, and then the other answer is 0. And we want all the values between and including the endpoints. So that would be both of them, 0 and 2. There you go. So that was one of the parts of today's lesson. We have some others that say find the average value of the function on the interval without integrating by appealing to the geometry of the region between the graph and the x-axis. So we're going to do the same thing, but without actually integrating. So we have these piecewise graphs. And we're going to try and do this one on -4 to 2. So let's get a graph of this because we're going to use geometry. So the picture is going to be very helpful. I'm going from -4 to 2. So I guess I'll give myself a little more room on the left side. All right. So I would graph both of these quickly first. Up 1 over 1, up 1 over 1, down 1, down 1, left 1, down 1, left, down 1, left 1, down 1, left 1. So that's one lines, and then the other one is 2 and it has a negative slope, down 1 over 1. So it looks like that. And then this one is from -4 to -1. So that's that chunk. And the next one is from -1 to 2. So that's that chunk. So that's your piecewise graph. And we're going to try and find the average value. So the average value, remember, is going to be, we could write it, the integral of the function from -4 to 2 divided by the base, which should be positive. So it's going to be 1/6. Now this right here is going to be the area under this graph. So we could do a little triangle, 1/2 base. Base is 6. The height is 4. And so the answer is 2. Average value is 2. I think. I guess I made a mistake. The height is actually 3. So the answer is 3/2. Okay, I messed up. This is 3. I put 4. 4 was right there. Okay, so the answer is 3/2. They're not asking us to find the c value. So we are done. Now, if we were to find the c value, 3/2, by the way, is right here. We would get 2 of them, one here, one here. We'd have to set this equal to that function, solve for it, set this function equal to that function, solve for it to get the 2 different places. But there's clearly 2 in the picture. Okay, 16 says f of t equals 1 minus the square root of 1 minus t squared, -1 to 1. So what kind of shape is this that we could use geometry on? Might be like a circle or a conic section or something, you know? So like if we were to call this y, be a, we could do, we could do y minus 1 equals -1 minus t squared, and then we could square both sides. So we do y minus 1 squared equals 1 minus t squared, which is kind of like x, and then we could bring that back over, it'd be like x squared plus y minus 1 squared equals 1. That's a circle shifted down 1, but I think it's just going to be the bottom half of the circle, shifted up 1 actually. So it's the bottom half of a circle shifted up 1 with a radius of 1. Shifted up 1. So that's the center. And this is the whole circle. Radius 1, shifted up 1. The center is at 0, 1. But it's just the bottom half. Because if you were to solve for y, you get plus or minus at some point, and they're going with the negative there, so that's the bottom half. So somehow we're going to pull this off with geometry. So f average equals the, I guess we could put t's here, from -1 to 1. And then we're going to divide by the base of the rectangle. So it's going to be 1/2. And then this area right here, what I guess our strategy could be rectangle minus half the circle gives you what's left. So the rectangle is base times height minus half a circle, 1/2 pi r squared. So it is going to be 1, and the half and the 2 cancel each other out, minus 1/4 pi. So that's it. That's the answer. And we would expect to get, it's like about a quarter. That's the average value right there. We would get 2 answers if we were to look for them, but we're not asked to look for them. So there you go. That's that one. That was kind of a crazy one. 31 says the directions say find the average value on the interval using anti-derivatives to complete the interval. So essentially, you find the average value like the normal way. So the way we find the average value is we integrate the function to find the area under the curve. We flatten it out like a rectangle and divide by the base of the rectangle, get the height of the rectangle. So cosine of pi is -1 minus negative cosine of 0 is 1. So it's plus, 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 plus. So we're going to get 2 over pi for the average value. Okay. 32, same kind of problem. 32 was y equals 1 over x e to 2e. So the average value is the integral of the function from e to 2e divided by the base, 2e minus e, which is going to be 1 over e, natural log of the absolute value of x, from e to 2e. So it's going to be 1 over e, natural log of 2e minus natural log of e. Now, we could clean this up. Natural log e is 1, right? In fact, but what we could do is we could use rules of excellence to split this up. This would be natural log of 2 plus natural log of e minus natural log of e. So we could say those cancel each other out, or that's 1 and 1, they cancel each other out. And then the answer is going to be natural log of 2 over e. That's your final F average. Okay. 35, one more of these. Y equals 3x squared plus 2x on the interval -1 to 2. F average equals the integral of 3x squared plus 2x dx from -1 to 2 divided by 2 minus -1. So that's going to be 1/3 antiderivative is 3x cubed over 3 plus 2x squared over 2, -1 to 2. So that's going to be 1/3. We plug 2 and it's going to be 8 plus 4 minus -1 plus 1. That's going to be 0. So it's going to be 12 over 3, which is 4. There you go. Okay. On to the next page. So 11 on this page, this says, find the exact length of the curve analytically by anti-differentiation. You will need to simplify the integrand algebraically before finding the antiderivative. So we are looking for arc lengths, lengths of curves. And so the formula that we derived was the integral of the square root of 1 plus the derivative squared. So that's the formula. Yeah, probably should memorize it. Okay. Okay, so we should find the derivative. Little power rule. Don't forget the chain rule. Okay, 3's cancel, 2's cancel. So the derivative is x square root of x squared plus 2. So we're going to plug it in, our length. Now, they should have told us, oh yeah, from x equals 0 to x equals 3 on this problem. So 0 to 3, the square root of 1 plus the derivative x square root of x squared plus 2 squared. So we're probably going to have to do a little work on this. So that's going to be 0 to 3. This is going to be x squared times x squared plus 2. And so this is going to be x to the 4th plus 2x squared plus 1. Now to integrate that, I think we're going to have to factor it, x squared plus 1, x squared plus 1, which is x squared plus 1 squared, which the square root cancels out. And so now we have 0 to 3 of x squared plus 1. Worked out nice. So now we can go ahead and find the antiderivative, x cubed over 3 plus x, 0 to 3. It's going to be 9 plus 3 minus 0 plus 0 is 12. All right, that worked out. Okay, let's look at problem number 12. So 12 is y equals x to the 3 halves from x equals 0 to x equals 4. So we need to find the derivative first. 3 halves, x to the 1 half. And we've got to plug it into the formulas. The integral is 0 to 4, square root of 1 plus 3 halves x to the 1 half squared. 0 to 4, square root of 1 plus 9/4 x. So, I mean, we could do u substitution on this if you want. U equals 1 plus 9/4 x. Du equals 9/4 dx. And all this is going to do is it's going to give you an extra 9/4. So I feel comfortable skipping u substitution. So I'm going to do 1 plus 9/4 x to the 3 halves, divide by the new exponent, multiplied by the reciprocal, 2/3. But there's going to be an extra 9/4 in front that I don't want, so I need a 4/9, which would come from this u substitution stuff. Okay, and then of course we have to plug limits in. Now, this is going to be what, 8/27. If you plug 1 in, it's going to be 1 plus 9. It's going to be 10 to the 3 halves. And you plug 0 in, and it's going to be 1 to the 3 halves. So the answer is going to be 8/27. 10 to the 3 halves minus 1. Seems fine. Okay. 14. 14 is x equals y to the 4th over 4 plus 1 over 8y squared. from y equals 1 to y equals 2. So are we supposed to do this? And then I think they give you a hint. Like, if you're going to do it with respect to y, then the formula changes a bit. The formula should probably be the integral of the square root of 1 plus dx dy squared dy. I'm going to do it with respect to y. And they tell you, they hint, hey, dx dy squared is a perfect square. I don't know. Meaning that probably makes it easier. Well, let's find dx dy. It's going to be 4y cubed over 4 plus, this is the same thing as y to the negative 2 on top. So it's going to be negative 2 y to the negative 3 over 8, which is y cubed minus 1 over 4y cubed. So that's dx dy. And then we're going to plug it into the formula. We're going to go from 1 to 2 of the square root of 1 plus this squared, y cubed minus 1 over 4y cubed squared dy. So that's going to be 1 to 2 of the square root of 1 plus is going to be y to the 6th minus 2. Now, if you multiply these together, the y cubes actually cancel each other out and you get negative 1/4, negative 1/4. So that's negative 1/2 plus 1 over 16y to the 6th dy. So this is messy. This is gross. Okay, let's see if we can do anything about this. Now, maybe what we could do is, fix this. That's going to be a 1/2, right? Maybe we could factor out a 16y to the 6th, the square root. So, or essentially give them at least common denominator with that. So then that would give you, if you divide it out, the same thing as multiplying by it. So this is going to be what? 16 1/2, 16y to the 6th, plus 16y to the 12th plus 1. Oh my gosh, this is so gross. Okay, I think we're getting there. So now we take the square root of 1/16 out. That's a 1/4 in front now. And then we have a 1 over y to the 3rd. And then this is going to be 4y to the 6th plus 1, 4y to the 6th plus 1. Still going 1 and 2. This is bad. Now this is 4y to the 6th plus 1 squared, and you take the square root, they cancel each other out. So now we have 1/4, 1 to 2 of 4y to the 6th plus 1 over y cubed dy. I think we're getting closer. So then this is, I'm going to distribute the division, and it's going to be 4y to the 3rd plus, and this is going to be y to the negative 3rd. So I think we can do it. We can do it. Okay, we're going to get there. So 4y to the 4th divided by 4 plus y to the negative 2 divided by the new exponent. 1 to 2. Can rewrite this a little nicer. It's y to the 4th minus 1 over 2y squared. 1 to 2. So you plug 2 in, and you get 16 minus 1 over 8. And then you plug 1 in, and you get 1 minus 1 over 2. Guess we give all these things least common denominators, which would be 8. So multiply top and bottom by that by 8. Top and bottom by that by 8. Top and bottom of that one by 4. So we have 80, 48, 128 minus 1 minus 8 minus 4 over 8. So it's 127 minus 4, 123 over 8 times 4 is 32. Oh my gosh. That was... There you go. There's the answer. 123 over 32. Crazy. Okay. Okay. All right. There are a couple more problems here. Let's see if we can fit them on here. Maybe. 36 says, find the length of the curve. 2/3. X to 3 halves. X equals 0 to x equals 8. I don't know. I'm just going to do this on a separate sheet. Really. I'm just going to try and fit it all on one sheet of paper, but I don't think that's going to happen. It's fine. Okay. 36. Find the length of the curve. Y equals 2/3 x to the 3 halves from x equals 0 to x equals 8. It's multiple choice. Doesn't matter. You got to do all the work. There's no way out of it. Multiple choice usually means more work, if anything. It's at least as much work. So we got to find the derivative. Okay. So square root of x. The length of the curve. So the interval 0 to 8. Square root 1 plus the derivative squared, which is 0 to 8, square root of 1 plus x. So this is a U substitution chain rule issue, but I think we can avoid it. All right, so it's going to be 1 plus x to the 3 halves divided by the new exponent. The derivative of what's inside is 1, so it's not even going to do anything. 0 to 8. So 2/3, square root of 9 is 3 cubed is 27, minus 2/3, 1, that's going to be 1, it's not 0. 54 minus 2 is 52 over 3. That's our answer, which matches answer B. All right, so I'll do the work. Okay, and then 37 says, which of the following expressions could be used to find the length of the curve? Y equals x to the 2/3 from x equals -1 to x equals 1. And all of these are in terms of y, which probably means we need to rewrite it in terms of x in terms of y. So you've raised both sides to the 3 halves. And you would take the derivative of x with respect to y. So we did a problem kind of like this, right? And you would then place it, and we'd use the integral. Now the other problem is, I guess we gotta find the y values that go with this. So y equals, if x equals -1, y equals +1. And when x equals +1, y equals +1. So this is kind of interesting. Now, so here's the deal. I guess we got to investigate this graph a little more. This graph right here is I think it's like a Siegel function. Kind of goes like this. So it's not differentiable at 0, which is an issue for finding length. So I think what we need to do is go maybe 0 to 1 to find one of these and then double it. So I think we'll do okay. So 1 plus 3 halves square root of y squared dy, and that let's see, that's looking like some of the options there. 9/4 y dy. So they all have this in them. The issue is that one of them has -1 to 1, which doesn't even make sense because the y values end up both being 1 from one end to the other. Because if you go from this end, the y value equals 1, and you go to this end, y value equals 1. So it doesn't make sense. If you did 1 to 1, that would just give you 0, which isn't true. So what we do is we're going to start at y equals 0 and do half of it and then double it because they're congruent. It's symmetric. So that one's pretty tough. That's answer A. I could see a lot of people going with answer B because they didn't change the limits at all. So there you go. And I didn't really want you to do 38. You can try it on your own if you want, but and I think I might have the answers in my work. I may, but it's pretty gross. I don't even want you to try it. So that's it.